Good evening. Am I audible?
Yes, sir. Yes, sir.
No.
I thought I'm late, but okay, just
No.
started.
Yeah, I was waiting for someone to join.
Yeah.
Okay. Welcome to week 11 of the live interactive session of the fabrication techniques for MEMS-based sensors, clinical perspective. The course is being taught by Professor Hardik Jitendra Pandya of ISC Bangalore, and I am the PMRF teaching assistant, Das Pandey from IIT Jodhpur. This is a brief about me, the Meet link, YouTube channel, and my email, and one additional information that I will be taking one additional class after, this one is the 11th week, right? So next one will be 12th, that will be the final. But on Thursday next week, not this week, next week, I think that is 19th. Yeah, on 19th, I will be taking one extra session uh, in which we will be covering, we'll be seeing how, you have seen most of the facilities which has been shown there. Now, I'll be showing the basic processes of microfabrication along with the equipments some equipments we have here in our lab or central facility along and the basic microfabrication processes in one lecture, like all the sequence of all the processes in one go. It will not be focused only on sensors or biosensors. It will be a complete sequence how we make some microfabrication device, like how we do the microfabrication or how we create one single sensor, kind of like the whole flow of processes. Okay. So before moving forward, if you have any questions, you are free to ask.
Sir,
Yeah.
actually, after today's session, the entire session, if it is, it will be better if you just tell us about that how to calculate the each rate in case of anisotropic. The
Oh,
second or third week, what we discussed now.
yes.
So,
Yes. Yes.
little bit about that. If you just
Okay.
give the overview, that will be better, sir.
Okay.
And
It's right.
particularly CVD, na, chemical vapor deposition. So there are different methods, right? So quickly
Mhm.
review of those if it is possible in today's session or in next week's
In the
session, but
next
it will
session.
be
Yeah.
better.
Yeah.
I was about to drop a mail, but I could not get a time. So I thought I'll just mention today so that in the
Okay.
next lecture also
So,
we can
like
discuss.
CVD and H rate, right? I think
CVD and
H rate.
eating rate, how
Yeah.
to calculate that? matlab,
Yes.
some expressions you were telling
Yeah,
that so that.
isotropy and these things like we discussed, right?
Yes,
This is
isotropic
something
anisotropy.
like a lot of confusion was there, right? So I will
Yes.
put one, two slides over it in details
Yeah, sure, sure,
and
sure.
we'll discuss. Okay. So let's move to problems for now. Today, like most of the lecture is about microscopy. So we'll be seeing more about microscopes. Identify the odd one based on the type of beam applied on the sample. Compound microscope, stereo microscope, inverted microscope, and electron microscope. So which one is the odd one out? Yes, any answers?
Electron microscope D.
D. And why is
Or
it so?
um, because compound microscope is a normal one, like which is then stereo we learned that. Then inverted also we are. Electron is only like which I'm not aware, but compound stereo inverted we electron microscope I didn't have
Yeah,
come across that.
it is saying on the type of beam applied, right?
At a time of
So
beam of light. Okay, beam
yes,
of light.
so in all this, it is light that is used, visible light,
Yes,
right? In
yes,
case of
yes, yes.
uh, electron is used. So in fact, the beam itself is different, right? So
Yes, yes, yes.
this is the same thing. So this I have put for reference because we will be coming up with questions about microscopes a lot. Okay, so here you see using a mirror. In case of a normal compound microscope, mostly uh, some light source might not even be used, right? A mirror is used which reflects the light from the environment, okay, and goes from here. Then we have stereo microscope, okay. in this case, we have a bottom light that is used to write in a sample, and sometimes we have top light also. Okay, such here you see knob is there, switch is there. Then inverted one, the concept is that the light goes from the, okay, sorry, here it is from here, and then it goes like this. The image is being seen from the other side, right? And but in case of electron gun is used, and electrons are bombarded onto the sample, and the reflection is recorded, and that is called as SEM, or like scanning electron microscopy, and these things. All these come under electron microscopy. Here, the source of light or source is electron. And why is it so? Why we are using electron instead of light? Any idea?
Electron beams.
See, when we are seeing things, it is something like, though we cannot see the light, but have you observed that when we go into a room that is fully yellowish in color, and when we go to some room which is red in color, okay, like the whole room is red, we have red lights. Have you been to some room where we have red light, or where we have blue light, something like that? Have you
Mm,
been to any such
no,
room?
sir. No.
In general,
Like, no.
if we try with a red light room with red light and a room with blue light, you'll see the difference in visibility, like how well you can see. Though
True.
both will have
Mm.
the same intensity, but we will be seeing differently. Why? Because both of these lights have different wavelength, and different wavelength makes, though that will not be much visible in case because we have big objects. Okay, so the visibility is limited by the wavelength. We cannot go, uh, like it is said that almost two times the wavelength we can see easily with that light. Okay, so if we have visible light, we can see something in the range of this only, Rayleigh criteria, 2 lambda, and this. But when we go to electron size, the electron size is much less. Its wavelength, the wavelength corresponding to electron is also very less. So we can see things in more details. Very good resolution is there. But the problem is that we cannot have this as easily as stereo or compound microscope. We can use stereo and compound microscope anywhere. It is not a very sophisticated instrument. Whereas in case of electron microscope, a lot of setup is there. In fact, we cannot move it easily. It is fixed, right? As well as it will have a lot of power consumption, vacuum is needed, a lot of other complications are there. Okay,
Okay.
yeah. So that is the reason we use, like when we talked about this also, like we can go to X-ray also. It will improve the resolution, just like we talked in lithography, right? If we go to lower wavelength, it will be having more resolution. But the problem is that there are other complexities we have to take in care. Okay, so electron microscope is the right answer here since it uses electron instead of light. Okay, a good practice is to disinfect the biosafety hood before its use. Hence, an efficient sterilization method would be hot air thrust, HEPA filter, UV rays, antibacterial wipe. It is saying that biosafety hood should be sterilized before use, right? So how we should sterilize it? Either we should blow some hot air thrust, or for sterilization we use HEPA filter or UV rays, or we wipe with it antibacterial wipes,
So UV rays
UV rays. And why not hot air thrust?
sterilizer, no? But yes, sir. What?
Why not
The
this
sterilizer, yes, hot air. Because
uh,
sterilization. No, so
yeah, and what about hot air? Like, can we flow hot air to sterilize the thing.
Yes, you can.
Yes, but it will be not that effective, right? The best
Hmm.
effective way is using UV rays.
UV rays.
Yeah. In fact, antibacterial wipes and hot air thrust will also work, but they will not be that effective like UV rays. Like it will have better reach and it will be easier for us, right? And what is the problem with HEPA filters? Can we use HEPA filter for this? Yes. Can HEPA
A
filter
filter
be
is a
used?
filtering, right? It's a filtering.
Yes, it
So
cleans the air.
sterilization.
Yeah, it is more about particulate air
Hmm.
contamination
Mm-hmm.
control. It is not related to sterilization. Though the big microbials, if they are in air, it will be cleaned by HEPA, like it will be filtered, but it is not going to kill it. It is not going to sterilize it. Okay. If 10x is the ocular power of a metallurgical microscope, what would be the objective power to get 400 magnification? Ocular power means the one that is near our eyes. Okay. Optical or ocular, it is said. Okay. Ocular lens. So it is saying this is 10x. So what will be the power of this objective that is near the sample or object to get
It will be 40 times higher, so that
40
10
times?
multiplied by 40
Yeah,
will be
10 multiplied by 40, we will get
400 times magnified.
400. Yes. And what is this metallurgical microscope?
Metallurgical microscope is that is to observe the like opaque this one and
Yes.
last
And how is
last week. Yeah, yeah.
yes. And how is it different from the normal microscope, like the compound microscope or stereo microscope?
Actually, it has like it is has a top as well as a bottom source, light source,
Hmm.
and this so like for what I'll say the principle. I guess it is based on both like transmission as well as reflection because it has top as well as the bottom source of luminate light source is there.
Okay, I will show you in later on. We will see it. Okay, it
Okay.
is somewhat correct, but the difference is like the principle is right that it is based on both. Okay, so this is 40x. Fine. We will discuss about metallurgical microscope later. Okay.
Okay. Okay.
A turret is found below the stage in case of metallurgical microscope, stereo microscope, inverted microscope, or electron microscope. Below the stage,
Inverted one.
inverted
Inverted
one.
one.
Yeah. So in case of inverted one, we find that a turret is there. Okay. Now, if you see the metallurgical microscope, there is one difference that makes it a bit sophisticated as well as a bit costlier. In all other microscopes, we use a light source that is may be around the around the objective, below the sample or anywhere. Here, the light source is in the this in the lens system itself. Okay, so here you see, and that also it is a polarized light. Okay, we have a light source
Yes.
that is reflected using mirrors and prisms, and from this itself, when you will switch on this system, from the lens itself, you will see a light beam falling on the sample. Fine,
Okay.
as well as this have this great advantage that it is very good to take digital photographs from this, though it can be taken from nowadays like this camera microscope cameras are used even on this stereo and compound microscopes. But in this case, it is very easy to take pictures because the light itself is built in. Like if we put the camera here, the microscopic camera and all, so it is very easy since the light itself, like it goes through the collimator and we can see very good images. Like there will not be circular patterns of light on it. In case of normal microscope, if you try to take an image, even if you take out nowadays we have mobile cameras, and if you try to take image using your mobile phone, even using macro lens, you cannot do that. It will have circular patterns of light. It is because the light is dispersed. Here, the light is properly condensed and put on the sample, and that also the light will fall only in the area where we are able to see the sample. Like it will also depend on the power of the objective. If the objective, like if you are going for like 1x resolution, not 1x, it will 10x resolution, and you are going for 30x and 40x. Okay, the size of light source that is falling on the sample will also vary based on this. In case of 10x, it will be a bit bigger. In case of 30x, it will be smaller. 40x, it will be even smaller. 100x, it will be even very small. Okay, so the area that is visible through this lens system, it illuminates that area only. Okay, and very precise, like only that area is illuminated and we can see that. Fine. So that is the purpose of metallurgical microscope, and it is certainly used to see opaque objects like silicon wafers and all. So this is the most common one you will see in microfabrication lab. Okay. When we don't have to see very small resolutions, you can go for this. Checking whether the etching has happened or not. These things are easily visible using metallurgical microscope. So the correct answer for the turret found below the stage is inverted microscope. Clear?
Yes, sir.
The type of pressure modules used in HEPA filters are positive, neutral, negative, atmospheric.
Positive.
Positive. I think we discussed this earlier also, right?
That's right. Yes, yes.
Yeah. So we always maintain a positive pressure inside the clean room so that things, some like particles can go out of it but cannot come inside, right? And that is maintained using the pressure modules in the HEPA filter. Okay, so inside it will always be having more pressure compared to outside. Like the air it is taking in, this will, whatever pressure this is, it will increase the pressure and then push it inside. So it will always have a higher pressure. Fine. So it is positive. The most commonly used biosafety cabinet for working with biosamples is class 1, class 2, class 3, or class 4.
Is it class 2?
Class 2. And which one is better? Class 1, class 2, class 3, or class 4? Which one is the best, having the
Actually,
highest
class
regular?
3, class 3 is better.
Hmm,
I mean, the
hmm,
4 will be better than that way
hmm,
because all the protection will be provided either to the product as well as the person and
hmm,
the equipment.
yeah. So,
The environment, I should say, the environment.
yeah, it is about biosafety cabinet. It is not about the clean room classes, right? I have put it here, but this one is about clean room. Okay, clean room
Okay,
standard.
okay,
Yeah,
okay, okay.
why it's not. This is clean room standard. I I placed it here. It should have been in the previous slide. Okay. So, like these are the class clean room standards. You can check what is the micrometer. This is from the ISO itself, and this is the FED equivalent. Many a times people talk in this. Even in India, we talk in class 100, class 1000 clean room, not the ISO. Okay, so it is the class 2 biosafety cabinet that is the most commonly used, though the stringentness will increase in class 4. Like it will be more stringent in case of class 4. Okay. Objective lens, electromagnetic condenser lens, backscatter detection, and secondary electron detector are part of which of this microscope? Scanning electron microscope, transmission electron microscope, both, or stereo microscope? Yes. Objective lens is there, electromagnetic condenser is there, backscatter detector, and secondary electron detector. So these are part of which type of microscopy? SEM, TEM, or stereo microscopy?
Is it both scanning and transmission electron microscopy? C.
Yes, it is both because both have the same system. It is just how they are detected. Okay, so if we see, it is like this. Electron source will be there, anode will be there, the condenser lens will be there. Here, in case of SEM, it is the scattered electron detector. Okay. In case of TEM, the whatever passes through the sample, that is again detected in fluorescent screen. So we can say that this is very similar to the inverted microscope version of SEM, right? Inverted SEM, we can say. Can we say it like that?
Yes.
Right. So it is like, though it is not that simple, like it will transfer through it, and it will also depend on what type of sample is there. Okay. It is more like X-ray imaging of the sample, you can say. How we do X-ray imaging of the body, we want to see inside what is the structure, right? So TEM is very much like that, and SEM is the surface scat scattering of electrons and reflection that we detect, that is on the surface. So what is the difference here? Okay, the backscatter detector. Okay, and here in this case you see backscatter detector and secondary electron detector. These are absent in case of TEM. Fine.
Okay. Okay.
So all other things are there. Electromagnetic condenser lens is there. Objective lens is there. But these detectors, they will differ. Instead of this, what is present there? There is fluorescent detector. Okay. So the detector differs in this case. Okay. So it is only in SEM. Though TEM also uses electron, but it will be different in the sense of the detector. Here, fluorescent screen is used. In this case, backscattering and secondary scattered electrodes are sorry, electrons are detected. Okay. So, which of the following light source can be used in a microscope? Tungsten halogen lamp, mercury vapor lamp, xenon lamp, or all of these? Yes. Which is the common lamp light source used in microscope? Yes. What you are saying?
Common is tungsten halogen. I
Yeah.
not sure, sir. No.
All these are used, in fact. And it is
Okay.
more about what I said, it is about the wavelength. Okay. So
Hmm.
changing the
Yes.
wavelength, we will get
Hmm.
actually intensity also will vary, as well as for different wavelength, we will get different type of resolution. Okay. Like
Okay.
with mercury vapor lamp and this halogen lamp, tungsten halogen lamp, it is still fine, like, but it will get hot. Okay, so we will need a
Yes.
cooling thing. Mercury vapor lamp also, it will emit uh, a lot of
My
heat.
lot. Right.
Yeah, heat, as well as it is not very good. It is a bit like we have to be very cautious. We have to cover it and
Mercury.
everything.
Hmm.
Yeah, okay. Xenon lamp also, like we cannot have. Uh, it is these things when combined with normal microscope will actually increase the resolution. We will get good resolution, but in that case we will have to have some fixed setup, like we will need some cooling mechanism, as well as some compressors, as nitrogen flow should be there, and these things, like complexity will increase. So it is like from light, normal visible light, we directly don't jump to electron. Okay, there are some other things also in between, like we can go to some resolution from this, but like if you can see very good resolution in case of SEM, people are nowadays not going for all this. But where there is no SEM available, such microscopes can help, where we have different light source. Okay, like good UV range and deep UV, or just starting UVA or UVB. These things can be used. Right? Any questions in this?
No, sir.
Okay. Using lift-off technique, platinum interdigitated electrodes with 5 micron features are patterned on a 3-inch silicon substrate. Okay, so we have a substrate of 3-inch, and we have patterned IDE on it, and the feature size, like the smallest size that is there, is 5 micrometer. Okay, silicon substrate is opaque in nature, we cannot see it through it, right? The feature can be better visualized under which of the following: inverted, metallurgical, stereo, or compound microscope.
Metallurgical. Just we discussed
Metallurgical.
for the book.
Yeah, just we discussed. And why is it so? Because the light source is condensed and put on the surface. Like we don't
Hmm.
have to see any kind of scattering there. It is very easy to see the surface. The type of detector that must be furnished in every laboratory to detect fire hazard is water, smoke, nitrogen, or light detector.
Smoke detectors.
Smoke detector, right? Since it is fire hazard.
Hmm. Hmm.
Usually, the working distance increases with increasing magnification. Is it true or false? So, what is the working distance of a microscope? Yes. Okay. It is false, right? It will
Okay.
not, like, the working distance does not increase with magnification, but it decreases. So what it is? So we have this objective lens system. Okay. So objective lens is mounted here. We have this sample here. Okay. So this is the working distance, like distance from the of the lens from objective lens from the sample. Okay, so if we are increasing magnification, actually the lens will come closer. So working distance will not increase, it will
Great.
decrease, right? So this is like when we are checking the sample, we want to go further. We simply go near the sample, not far away, right? So if we are trying to see more magnified image, and this is more true about systems where we change the magnification by just by changing the distance between objective and eyepiece, right? When we have this compound microscope, then we like there is a range. Mostly we directly say this is 10x, 20x, it's fine, but still it will have range 10x and 10x. So 100x will be there, but it have some range. Like it can be somewhat like we can say like total will differ from maybe 80x to 1 100x, like that. Okay, so that variation we can bring by changing the working distance. But in case of compound microscope, so what we do is that once this range is over and want to go to further, we just switch the lens system, objective lens, and go to the next objective lens that is having more resolution. Or in case we want to see less, like we want to see bigger area for lower resolution. So still there, we have to change the distance, and working distance will be inverse. Like it is the magnification is inversely proportional to the working distance of the lens or the microscope. Suppose an image is taken by a microscope with light passing through following objectives. So it is 5x first, then 10x, then 100x. So we have multiple objective lenses. One is say 5x. So let's consider it is just a simple light source, and light passes through 5x. Then there is one which is 10x. Then there is 100x. So what is the total magnification that will like how much magnified image will be there? Say this is the image we are seeing, and let's consider that we are just taking it directly into a, like using a camera, and we are seeing it. So what will be the magnification of this image? Here no eyepiece is being used, only objectives. Sorry. Yeah. Any answers?
Not aware, sir. Not getting exactly. So we
Uh,
have to calculate it, effective
yeah.
magnification.
Yes. So it is saying that the image, like the light that is reflected from the sample, that is passing through a lens, that is first it is magnifying it by 5x, then there is another lens that is magnifying it by 10x, then it is magnifying it by 100x. So what is the total magnification that we will get?
Total magni.
Yeah, total or effective magnification at the last.
Totally. Okay, okay. Then 5, 10, and 100, na?
Hmm.
So it will be 50 by 100. So it will be 5,000 times.
Yes, it will be 5,000. So we just multiply it 5, 10, 100
I
by
thought there is some angle or some. Okay, understood
nothing.
now.
Simply it is like first multiplying it by 5, then
Yeah,
that 5 times image that is again getting magnified 10
multiplied
times.
and
Yeah,
magnified.
then again that 500 times magnified image is magnified 100 times. So multiple objectives are being used to get very high magnification, and in this case it will be 5,000, right? 5,000, yeah. So total magnification will be 5,000. Nowadays, like many these microscopes have shifted from you having a eyepiece to either having a digital screen inbuilt or having a camera that can be connected to PC. Okay, and they are using such things. They are using multiple lenses in objective, no eyepiece. The camera itself is the eyepiece, and that is taking like now there are microscopes because people are not very like it is not very handy to look through it. Like earlier, it was fine, but now technology has improved, so people like recent ones I have seen like they are using some screen, either some small tab kind of structure, or they are
Mm-hmm.
providing the connection to the computers. You can have direct input to the computer, and you can take the pictures and all. That is very convenient nowadays. Right?
So then what are the questions will be based on the contents covered in this course, or it will be the latest, also will be based on the latest technology
The, the
or
questions
the
are like questions will be covered from the course only, right?
course
This is
contents,
yeah,
what
course content. Yeah,
design.
what
Okay.
is
Okay.
covered. It is something like we must be aware since if we are working in this
Okay.
field, we must be aware what is
Yes.
happening
Sure.
around us,
Okay.
right?
Okay. Okay.
And like it generally happens that we are adopting technology much later than our counterparts like US, Europe, and all.
Hmm.
And that
Hmm.
is the
Hmm.
reason, like, that is a major reason I think that people after doing their graduation or masters here, they are preferring like, let's go to Europe,
Higher
let's go to
education.
US
Hmm.
to
Hmm.
study, right?
Yes.
Because we are a bit late in adopting
10 years or
technology and
20
this.
years back.
Yeah,
Okay.
no, nowadays, like in research field, certainly India is progressing a lot in the sense
Progressing.
that
Yes.
yeah, we are having very good technology equipments and all like
Yes. Yes.
but still the problem is
Now
that
we'll
all
be
of those
self-reliant.
yeah, and still the problem is that we are importing all those equipments from outside. We are not making
Okay.
them. So that is a problem, and I think that is the reason that such courses and these things, even IIC have a program where uh, people can learn about
Yes.
microfabrication, hands-on microfabrication, and this. Just to improve this scenario, the government and educational institutes are trying a lot so that we can have these things manufactured in India and all. Every instrument we import from outside, even small
Okay.
things. So that is even the chemicals are
Um,
imported.
okay.
Like
I have one question. मतलब अभी it is not related to that
yeah,
directly, but
yeah,
it's just I recalled. So
yeah,
so many times I have to ask, but I just forgot. So
yeah,
even though it is not related to immediately with this topic or question,
yeah,
I'll ask
yeah,
that. So whenever
yeah,
we are saying that a clean room, na, class is
yeah,
like 10,000 or
yeah.
2,000, 10. So how
Hmm.
will you measure it that, okay, now it's a 10,000 particulate are there or 1,000 is there? Is there any instrument by which we are measuring it?
Mostly it is about we are having these filters, right? So
Hmm.
how much particles are uh, being filtered now? In the sense, we
Okay.
are continuously running the filters. So on the filter,
Mm.
how much particles are being found? That actually
Okay.
determines. Like we divide with time, that is the flow. Like there is some
Uh,
flow rate of air as well as
mm.
some time for this duration. This much air flew through this much area, so that in this
Mm.
volume, how much
Mm.
particles were trapped.
Mm.
So
Mm.
that
Mm.
is
Mm.
the way to find it out.
Okay.
It is
Okay. Okay.
not done actively inside the chamber, but it is like
Okay.
from the on the filter, how much particles are getting trapped. Like there are different levels. See, zero point
Mm.
0.5
Mm.
micron filter,
Mm.
like
Mm. Mm.
different. So that particle will only be filter on that
So we
side.
can say that the classroom that class we are defining 10 or 1,000, it depends on the filter ka screening dimensions, whether it is
Yes,
uh, 2.5 micrometer or 1 micrometer that way.
yes. In
So that
fact,
we can guarantee that. Okay.
that is HEPA filters. This
Screen size. Mm.
screen size.
Mm.
Yeah, Sieve
Screen
size,
size.
exactly.
Sieve.
That is, yeah, that is what will determine the class. But along with that sieve size, like HEPA is not a passive filter; it is an active filter. It works on
Yes.
ionization and this thing. So sieve size plays a role, as well as when we go to smaller size, we it is like th those particles, they are like there are dust particles. One thing is that if it is a bit bigger, it will be filtered, right? But if it is smaller, what we do is that ions, like the gas is highly ionized, and around it, like that particle gets ionized and it sticks very much like a static charge, right?
Okay.
Like we
Okay.
comb the hair and like papers that like get attached to that, right? So it is
Yes. Yes.
like
Yes.
we have a very charged environment, and in that the particles get charged and they stick to the surface. And now on the surface, we know how much particles are there. Okay, on that surface, the
Okay.
ionized surface,
Okay.
and then we are able to get it.
Okay.
Fine. Okay. Which of the following type of microscope enables 3D perception of the subject by gathering light from two optical paths? Is it compound, stereo, inverted, or electron microscope? It is saying that 3D perception of the subject. Yes,
3D or be stereo microscopes sir, because
yes, continue.
it is what is I have guessed because I just read, I so recalled, not
Yeah.
stereo.
Anyway, like whenever we have,
Because,
whenever we want 3D, or like we say that the
hmm,
perception of space, right? It is always based on two, right? If you close your eyes and hear from your ears, we can make out
hmm,
from which side the sound is coming, right?
hmm,
But can you do it with one ears only? Close one ear and hear from other ear. Only one ear. You cannot make out from which side the sound is coming. Similarly
yes.
for our eyes, if we see with only one eye, we can if you put two things like side by side like this and just see it with one eye, you will not be able to distinguish which one is near and which one is farther.
Hmm,
Okay,
hmm,
it is by the virtue of having two eyes that we are able to see three things in 3D. The distance, right? Because there is slight change, slight difference in the image of the left eye and right eye. So to enable that thing, to make that feel of the 3D perception, the stereo microscope is used. And in this case also, we will see the same object from two different angles, slightly separated by the distance of our eyes. So it is like objective is same, but the uh, eyepiece or ocular piece is different,
I
and
mhm.
that makes the difference. Like that makes us perceive the 3D perception. So like if you have some deposition like this, and around it, like suppose it should have been cut like this, but some step kind of structure is formed. Okay, so if you are seeing just with one, you will not be able to make out that there is a like what we say, there is step kind of structure, right? But if we are seeing using stereo microscope, we'll be able to see that there is some step kind of structure, some up downs are there, right? So that is the reason we are using stereo microscope. Resolving power of a microscope is function of wavelength of light used, numerical aperture of lens system, refractive index, wavelength of light used, and numerical aperture of lens system. Which one of these?
Is it the numerical aperture, the lens system?
Okay. And so it is saying resolving power. Resolving power is like the resolution or the
Hmm.
smallest thing we can see. Okay. So it, like we have discussed earlier also, it will also certainly it will depend on the numerical aperture. That means how much light it can collect, like the lens system, how much light it can collect. That is one thing. Second thing is the wavelength of the light used. If we are using smaller wavelength, we can go to higher resolution. Remember, we talked about this earlier also. It is based on the Rayleigh criteria.
Smaller
Rayleigh for
wavelength. Other.
Yeah, wavelength is directly proportional to the resolution, not resolution. What I will say, it is inversely proportional. The higher the wavelength, this is not. It is not directly the resolving power. This will be the smallest resolution. Like smaller this epsilon, better will be the resolution. So it resolution will be, we can say, 1 upon epsilon. Okay. So it is directly proportional to, so like if we invert this, it will be something like numerical aperture by 0.61 into lambda. Okay. So lower wavelength will give us better resolution. Okay. Relief criteria says to distinguish, uh, like to distinguish between two things, the minimum distance that is required will depend on this constant 0.61 lambda and the numerical aperture of the lens. So if we want to go to the resolution, that is not exactly 1 by epsilon, but resolution is somewhat dependent on uh, the smallest size you can differentiate. Okay, that will give us the resolution. Smaller this is, like if we can see, like suppose there is like from this camera system, you are able to differentiate between these two, right? These are two, like these are at some gap, but if I put it very close, maybe through the camera you cannot see. Is this pen visible? Is Are these visible to you? Hello.
Yes, yes.
Yeah. So it is like when I am putting it very close. Okay. I think you might not be able to see that they are at some distance.
Yes.
Okay. The distance, though there is a distance. So it is based on the numerical aperture of my camera as well as
Hmm.
the wavelength of the light, that you are not able to distinguish between these two. So that is
Okay.
having a lower resolution than the than my eyes or maybe some lens system that will be able to differentiate. And even when I am keeping it very close, right, from my naked eye, I can say that they are touching each other. But if I see through a microscope of very good resolution,
Hmm.
it might be
Hmm.
that there is a difference. Okay, so that microscope resolution, the ability to distinguish between the distance or see the distance uh, clearly, that will depend on the light source being used, the wavelength of the light source. Lower the wavelength, better I can see the distance or the gap. Higher the numerical aperture, I can better see it. So higher numerical aperture will be able to capture more area. So you see that the same resolution of cameras when we are using this DSLR cameras and all, and when we are using the same resolution in our mobile, we get different kind of photo, though the light source is same. So what is the difference? Like people are using DSLR camera of 16 megapixel, and we
Hmm.
have 48 megapixel cameras in our mobile. Still, when we see the quality of image that we get from a DSLR camera of 16 megapixel, it is much better than 48 megapixel. Yeah. So what is the difference? Hello, you are not audible. Are you saying trying to say something?
Uh, no, no, I'm not saying. I'm just thinking on that only. That whether it's
Yeah.
a
So if you see, like,
numerical aperture.
yeah. So if you see the camera, like this is mobile camera, right? So if you,
Mm,
this is visible, right? So
mhm,
if you see the, don't see this big size, right? The actual lens is
mm.
this small black one,
Inside it.
right?
Yes, yes, yes.
Inside it. So it have very small area. Numerical
Mm,
aperture is that area. But actually, if you see a DSLR or a simple point and shoot camera, this whole round thing that might be the size, or even more than this whole can be the size of the lens there,
yes, yes, yes.
right? So that makes a huge difference. A lot of difference
Definitely.
is there. You see, even though we have lower resolution, we will get very good quality just because their numerical aperture is high. That is why
Mm-hmm.
you see nowadays the size of camera, size of the lens in cameras in mobile cameras is increasing gradually.
Incredible. Mm-hmm.
Yeah, they are making bigger, 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 or they are going for this software processing to compensate that. Okay,
Mm-hmm.
so this plays a very important role. So how much light it can uh, capture? Like if it is big lens, it can have a lot of light.
Yes, yes.
Certainly, along with,
Mm-hmm.
yeah, along with that, there is one problem that generally occurs is that color aberrations will be there, but you will be able to see things more
Mm-hmm.
clearly.
Mm-hmm.
The color might get changed a bit from the original one,
Yes, sir.
but you will be able to see the things more clearly. So it will depend on numerical aperture as well as light. So you might have seen that some cameras use IR light, infrared
Mm.
light, for better visibility, even during night time. We can see
Mm-hmm.
the things. So that is again this lambda. So
The lambda.
yeah, lambda. So that is the wavelength. Infrared is having lower wavelength,
Yes,
right?
yes.
So we are going to lower wavelength for better resolution.
Higher resolution.
Yeah. So resolving power of microscope is function of both wavelength of light used and numerical aperture of lens system. Fine. The greatest resolution in light microscopy can be obtained with longest wavelength of visible light used, an objective with minimum numerical aperture, shortest wavelength of light, or short wavelength and maximum numerical aperture.
So just now we discussed
Yes. So
shortest
if you
wavelength and maximum numerical aperture.
maximum, so we have to use a light that is shorter, and that is why you see like gradually. No, IR don't have high resolution. Don't have lambda less. IR is used for intensity. Okay, that is a different thing. Yeah, I said
Okay,
the
okay.
IR is not having lower
Very
wavelength.
for
Yeah,
okay.
yeah. It is not having lower wavelength. It is about IR reflection is there and all. That is a different thing. Okay, so shorter wavelength and maximum numerical aperture, and that is why you see gradually if we increase from this visible to UV, deep UV, X-ray, and then electron. Okay, the quality will, the resolution will increase. Okay, I think that I have put somewhere. Okay, I will. I think I have put somewhere that list how it goes. Okay, so
Okay.
which part of compound microscope helps in gathering the focusing light rays on the specimen to be viewed? Okay, so is it eyepiece lens, objective lens, condenser lens, or magnifying lens that gathers the light and focuses it on the sample? And this we are talking about compound microscope. Yes. Any answers? Yes. Any answers? Any guesses? Yes. So we have to focus the light on the specimen. As I discussed, in case of metallurgical lens, the
Hmm.
metallurgical microscope, it is being done inside the objective itself, right? In the objective itself, I said no, that the focus area will differ according to
Hmm.
magnification, like that is being done in the objective. But in case of a compound microscope, there is something called as condenser below the specimen. So it tries to focus the light to one place. So it is simply a lens that tries to, like, if we are saying that this is a mirror and light is coming from an infinite source, like that is very far away or from the environment. So the reflected light will all be parallel. So to make it focused like this, is this are these rays visible? What I am tracing. So
Yeah.
it will the rays are there. We focus it to the specimen. So it is also a lens that actually concentrates the light to one place, tries to concentrate, and it will have a focal length of almost this size, slightly
Hmm.
bigger than this, because we don't want a very pinpointed one. We want a bit bigger so that we can see it also, right? So the focal point will be a bit more than this, somewhat here, right? So that is the condenser lens. It has no role in magnification. It will not magnify our image, but it will help us see it clearer, because one thing is that, yeah, we are talking about all these things in the resolution, but what you will see and perceive, that will also depend on the intensity of the light, right? So in this case, if it is dispersed, you might not be, even though we have good numerical aperture and everything, we might not be able to see things clearly. So this, what it does is that it actually increases the intensity of the light that we are seeing through, right? Which part of the light microscope? Light microscope means the simple one that controls the intensity of light entering the viewing area. Coarse adjustment screw, fine adjustment screw, diaphragm, or condenser lens.
Just now we discussed so condenser lens
That is, that concentrates.
for compound. Okay.
It is saying the intensity we have to control. So what happens is that sometimes uh, this intensity is not always good. It can also have a problem that we might want to see, we might want to like see, we want the light to decrease like a bit less. So in that case, what we do is that we put a diaphragm. Okay, so diaphragm is somewhere here. Okay, that by adjusting the diaphragm, we can control the intensity of the light. Okay, how this will concentrate, and then we change the diaphragm, and we will be able to, like, lighten or darken the image that we are seeing. Okay, so there is in the microscope there is a small adjustment near the condenser. You will see that from where we can change the intensity, like it will not be circular, a bit like a knob that we can move forward and backward, so that will increase or decrease the intensity. And in case of a metallurgical lens, you just have a knob that will increase or decrease the intensity of the light from the source, like we have a separate source for that, right? Yeah. Which of the following microscope works best on the transmission of light? Metallurgical, stereo, or inverted?
Both the metallurgical as well as inverted one.
Yes.
Only the
And
stereo works on the reflection, but
reflection.
metallurgical both works on both actually.
Yes. So it works on reflection. Metallurgical works on reflection as well as transmission of light, since the transmission occurs through our objective
Okay.
itself. Yeah. And inverted, we put the light such that there is a transmission, right? Okay. Suppose that we have an eyepiece provided, suppose that our eyepiece provides a 10x magnification, okay? And objective is set to 20x magnification. So what is the total magnification? Well, I think magnification problems we have done a lot, right?
Yes, it's 200.
200. So simply we multiply it, we get the magnification. With increase in magnification of objective, the working distance
Decreases.
decreases. So there it was true false, it is here increases or decreases, right? So it decreases. Okay. What is the correct sequence of lights in decreasing order of energy? Remember, it is talking about energy. It's of energy.
Decreasing order of energy.
Energy, or you can say intensity. Intensity will also not, we cannot directly say intensity, but for the same parameters, we will get higher intensity. Okay. So so what will be the correct sequence of this?
No, sir, no idea. Sorry.
Okay.
I can't
So
recollect.
it is very much in the same sequence as this wavelength. Okay.
Mm,
And
mm,
if we remember the Waveguard, the sequence will be something in that
mm,
only,
mm, mhm,
either
mhm.
forward or
Okay.
reverse. Okay.
Okay.
So uh, yeah. So if we see like this, it as the wavelength increases,
Mm,
the
mm,
energy decreases. You see, the energy is increasing in this side, right? Energy in electron volts. It is minus 8, 10 to the power minus 8, minus 6, minus 4, minus 2, going
mm,
to 10 to the power minus 8. So as I was saying, like red having the lowest energy, okay, as well as the highest wavelength. Highest or not highest, we can say largest wavelength. If we see the visible light, okay, and
mm.
as we go further in this side, so it will be increasing the energy. So red will have the lowest energy. This violet will have the highest energy. Generally, we are not able to see violet light that clearly. Okay, so we generally talk about blue, right? Like when we talk about light, I think violet light is very uncommon, and not all part of violet is visible to us. Okay, like we are able to see violet, but not complete violet thing. Like that is the that is very short range of violet we are able to see. Okay, so blue. What were the options? Blue, green, and yellow. Blue, yellow, green. Okay, it is about blue, green, and yellow only, right? So blue here, green is here, and yellow is here. So which will have the highest energy?
Blue one, na? So,
Yeah, blue will be having the highest energy, followed by green and yellow. And it
hmm,
is very similar to the wavelength. Like we can say inversely
hmm,
proportional to wavelength. Okay, so having the lower wavelength, so blue will give us more energy, lower wavelength, and so blue light will have better resolution compared to red or compared to yellow or compared to green, right? So if we are using a blue source of light, we can get better resolution. If it is pure blue, like we are not mixing it with any other, right? Compared to having this. And that is why when we are having white light, actually we are having all the source, right? And you might have observed that generally, uh, if you have some blue patterns, okay, and then you have like, okay, this is red now. Mm. And then we have some blue patterns. And these are too far, I think. Yeah. Okay. Blue. This is like with your naked eyes, you are seeing this blue pattern, as well as if we have some red pattern. And if you see both of these, okay, the clarity will differ since we are seeing under sorry, we are seeing under the same white light. I think maybe through the screen it will differ because screen have different kind of lights. But if we are using if we are viewing this uh, on simple plain sheet of paper also, we have white light that contains all the light. So from the blue part, blue light will be reflected, and from red part, red light will be reflected. So blue have more clear visibility, and that is why you might have seen that generally in this formal presentations and all, people prefer blue font and everything because it looks clear. It is more about resolution, like things will not merge, like small differences will also be clearly visible in case of blue compared to red.
mm-hmm.
Okay, so and some people even blue and yellow, the combination of blue and yellow is the most preferred one mostly, right? So and then there is green in between. Okay, so what will be the correct sequence of energies? It will be blue, green, followed by yellow. So blue will be having the highest energy, and wavelength exactly the opposite. In case of wavelength, it will be blue will be less wavelength, green, then yellow. Fine. Yes. Any questions still here?
No, sir. No.
Okay. Those two, I will put some slides. Okay. Uh, I will put some slides in the next class, and then I will
Yeah, yeah.
explain.
Sure,
Yeah.
sure, sure. Actually, I was
Yeah.
about to put that message in the next previous week only, but I forgot to
Yeah.
drop the
Sure.
mails. So,
And anyway, like
no,
if it is next week, I will cover for sure.
okay,
And if
okay,
I am
sure,
not
sure.
able to, like that, I will cover in the Thursday class if there is no time. But
ठीक है.
we have time. Like mostly we are left with time, right? So,
Hmm.
any other questions?
No, no, no. Because abhi now to everything, all the weeks, because during that week we are learning, na, so that week
Mm,
assignment or immediately whatever we are discussing. But now if
mm.
the previous one is asked, then little bit
Yeah,
confused. So let's
yeah.
see how
Just
we
revise.
can.
I have put all the slides, right? So just go through the questions. I think that is a good way. All the questions are available to you at
Yes,
one
yes.
place.
So I was
Yeah,
going through that. That time itself, I came across that third week
third.
problem, na, that
Yes,
anisotropic thing rate, and so
yes, yes.
little bit I got confused. So I thought I'll ask you again so that it will
Mhm.
be clarified, more clarified.
And that is a very important topic, like how much because it defines how your structures will be
And
formed and all.
yes, yes, yes. And also, if you could give more insights on the bonding, like what
Bonding.
kind of bonding is required, direct or
Hmm.
like vapor to vapor, vapor to glass, so how it is.
Yeah,
Little bit,
bonding is,
just a quick
yeah.
recap or the review kind of thing, so it will help to brush up the
Okay,
things. That's
I will put that. Sure.
if it's
Bonding.
possible, I'll
Yeah,
do that,
not
but
an issue.
still.
And in fact, bonding and this I will anyway be putting in that final class. Okay,
Okay.
so that I will put in all the processes. I will put what are the processes, and what we have done is that in different weeks we have studied different processes separately,
Hmm.
right?
Yeah.
So a complete sequence of processes, like how it is done. If suppose we are going to make a, say, gas sensor or a pressure sensor or a biosensor,
Hmm.
okay,
Hmm.
what is the sequence that is followed?
Hmm. Hmm. Yes, that is
Okay,
also yes. Yes.
what is to be done and where it is to be done, what are the processes that I will try to cover. Okay, in that
Yeah.
mostly these
Sure.
things will be covered. Okay, I will
Sure.
try
Sure.
with gas sensor because I am more comfortable in gas sensors. Okay,
Okay.
gas
Okay.
sensor and pressure sensor maybe. Okay, like I am
So it
mostly
will be
working in
covered
gas
in
sensor.
on the like in the next week itself, no, sir? 18th.
Next week,
That means on 18th.
17th is Tuesday, so
7th,
I think 19th, Thursday 19th.
19th.
I have yeah,
Okay.
I have
Okay.
put the request. So I think that will be announced or but
Acha, so on 19th. Okay, ठीक है, no issues, no issues.
yeah, and that will be put in the classroom also. I think they will
Hmm.
announce as
Okay.
well as like the meet link. Everything will remain the same, so not an issue.
Hmm. 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 ठीक है, sir.
Okay.
Thank you so
Yeah.
much, sir.
Thank you. Okay.
Yeah.
So see
Thank you.
you in the next class.
Yeah.